So we're going to start talking about transformation of our functions. We've already talked about exponential graphs and log graphs. But now we are going to start transforming them, which means sliding them or reflecting them. So let's just review a little bit from prior chapters. So remember that if there's a negative out in front, that negative tells me that I reflect it over the x-axis, flipping it upside down. The number in here with x tells me whether I go left or right. And the number at the end tells me whether I went up or down. So your basic y is equal to x squared problem was something that looked like this. And then if I gave you that 5 x minus 8 squared plus 3, instead of starting at the origin, I would go to the right 8 and up 3. And my picture would be something like that. So we're going to talk about those again. So the first one, we're going to describe the transformations with exponential functions. So remember, exponential functions, you can actually see the x variable up in the exponent. So this here is a variation of this graph. So if I graph this original one, we know that it's decay because this number, this base, is between 0 and 1. So our picture is going to look like that. Now the difference is this minus 5, and since it's at the end, it's going to go up or down. But because it's a negative, we are going to go down 5 units. So 1, 2, 3, 4, 5. So now my picture looks like this. It's the exact same shape, it's just moving down 5. All right, so this one, this original function before all the changes, is just e to the x. That's just your normal graph. And e is bigger than 1, so it's growth. So it's going to look something like this. Then this minus 1 means I'm going to go down 1. But then there's a number in here with x, and because it's in with x, we go left or right, but it's always the opposite of what you see. So it says plus 2, so I'm going to go left 2. So I'm going to take that same picture here and just go left 2. Now let's talk about the asymptote. Now the asymptote from the original graph is always going to be the x-axis, which is the equation y equals 0. So if I just moved everything down 5, my new asymptote for this new function is going to be y is equal to negative 5 because I moved everything down. All right, so the original asymptote here was the x-axis, which again is y equals 0. And then since I moved it down 1, my new asymptote is going to be y is equal to negative 1. But then I went and moved it to the left 2. Well, if I take this horizontal line and I move it left 2, that's not going to change. So this is my new asymptote. So now let's talk about describing transformations with logarithmic functions. The rules are not going to change on you. Okay, if there's a number in the parentheses, with x, we are going to go left or right, but it's the opposite of what you see. The number at the end tells you whether you go up or down. And then if there was a negative out front, that would be a reflection over the x-axis. So those are the exact same rules that you were taught in Chapter 1, the exact same rules that you were retaught in Chapter 2, and the exact same rules we talked about up here. So this function, before it got changed on us, was just plain old ln x. So ln x has this y-axis as an asymptote, and we come up along it and we curve off. So now if I throw in ln x plus 6, because it's in with the x, we're going to go left 6. So now my picture is going to come up along there and curve over to the right. So the asymptote here remember, was the y-axis, which was the equation x equals 0. But now because I went left 6, my new asymptote is going to be x is equal to negative 6. So the first half of this assignment is just, do you know, 1, what the original graph looks like sketched? 2, can you find the asymptote of the original figure? 3, can you slide, transform these, move them left, right, up, down, and know where to go, and come up with a new asymptote? But one of the biggest concepts that you need to grab from all the notes so far is, where is everything happening in the actual equation? Where is it located? So now let's talk about how to graph these. So what we're going to do here, same as we did before, is we are going to rewrite, and then we're going to make an XY chart. But sometimes, depending on the problems, we may have to do some other work first. We can't rewrite unless our log base something of something is by itself, which in this case it is. So I'm going to go 4, loop it over to the other side of the equal sign, and then come back. Now I'm going to go ahead and make an XY chart, but before I can make my XY chart, I need to get x alone. So we're going to plus 3, plus 3. So we're going to say x is equal to 4 to the y plus 3. Since my variable up in that exponent spot is y, I'm going to put my numbers here. And now let's plug it in. So if I plug in negative 2, I'm going to get 3.06. Negative 1 is 3.25. Next to 0 is 4. Next to 1 is 7. And next to 2 is 19. Probably not going to graph that. So let's graph the other one. 7, 1. 4, 0. 3.25. 1, 2, 3.25. Down 1. And then 3.06 down 2. So let's talk about what's going on here. Because of this minus 3 inside here, we know that the graph was going to shift to the right 3. So my old asymptote was here. So if I shift to the right 3, here's my new asymptote. And so my graph should come up right along the asymptote and then veer off. And now we want to label the equations and the intercept. So the asymptote is now x equals 3 because it's 3 to the right, cutting through the x-axis. And your intercept, you can clearly see it's hitting right there, 4, 0. This one is very similar, but there's not parentheses, so first we need to get rid of that 6. If you don't like the way it looks here, let's rewrite it this way. Maybe this will help you out. We still have log 4x on one side and y minus 6 on the other. So we're going to loop-de-loop. We're going to write 4, flip over here, and then come back. This time x is already by itself, so we don't have to worry about doing anything else. Because of the y up here, we're going to put our negative 2, negative 1, blah, blah, blah. If I were to go ahead and plug in negative 2, my calculator gives me an answer in scientific notation, so let's not do that. Negative 1, same thing. 0, same thing. 1, still going to give me in scientific notation. Let's start with 2. And because we bypassed so many of them, let's do like 2, 2.5, 3, 3.5. Let's see if that will help us out. So the answer next to 2 is 0.004. That's really tiny. The answer next to 3 is 0.015. All right, next to 2.5 is 0.007. Next to 3.5 is 0.03. How about some bigger numbers? How about we try 7? Let's jump up to 7. 7 will give me 4. 7.5 will give me 8. So let's plot a few of these. Over 8, up 7.5. Over 4, up 7. And then 0.3 is barely there, 3.5. 0.15 is barely to the right, up 3. And so here's my graph. It comes up along here and then starts to curve out. Now the asymptote is the same spot it's always been. So that's going to be the y-axis, or the equation x equals 0. But your intercept, you know it's going to be somewhere here, you just can't see it. So this is where we go back to where we know the knowledge of an intercept. So since I'm looking for the x-intercept, the y we know for a fact will be 0. So we need to plug 0 into here. So if we type in 4 to the negative 6, our calculators might give us something like this. This is what my calculator does. So this is in scientific notation. It's telling me to move the decimal point 4 times, but to the left because it's negative. So 1, 2, 3, 4. So 0.00024. So that's what goes right here. So you knew it was really tiny, you couldn't see it, so we actually have to go back to the equation. Now the same one here, but I want to show you this one's slightly different. Because of this minus 2, think of this as 1 unit here. We got to get rid of that minus 2, so add 2 first. Which I could just write like this if I wanted to. Same thing. Remember ln has an invisible e here? So we're going to go e raised to the y plus 2 is equal to x. Now use your E button on your calculator. Okay, probably don't want to graph these, so let's pick some other coordinates. So negative 2, negative 1, 0. We could do maybe like negative 0.5, negative 1.5. So our graph's going to come right along this asymptote and it's going to shoot out here. The asymptote, again, is the y-axis, which is x equals 0. And the intercept way over here, if you can't see it, let's look at the table. It's 7.30.